All right, we are recording. Okay. So, guys got ticket stubs. And he sorts them into piles, going off my memory here. I think it was 10, 15. Oh, is that correct? Yeah, okay. And every time he does, so he may have 4 piles of 10 or a couple piles of 20 or whatever. So he stacks them up in piles of 10, 15, and then 20. But if he does it 10 piles of 10, he has 2 ticket stubs left over. If he sorts them out into piles of 15, he has 2 left over. If he sorts them out into piles of 20, he's got 2 left over. So that's a remainder. Right? So that's where the modular stuff kind of kicks in. So what I'm going to do is I'm going to look at 3 modular equations. Say, well, let's find all values x such that it's congruent to 2 on 10. And then, and this was problem number 10, if I remember it. So then we'll look at, if you sort them out in piles of 20, I'll find all numbers congruent to 2. Or, excuse me, minus 15. And then piles of 20. Now, the idea is it says, what is the least number of tickets he can have, assuming he's got more than 2 tickets. So what I'm going to do is I'm going to start writing out all these numbers that are congruent to 2 mod 10 here. So what could x be? Well, certainly x could be 2. It could be 12. In fact, all I got to do now is add 10. And the idea is, again, that 12 minus 2 is 10, which is evenly divisible by 10. So the next number will be 22. 22 minus 2 is 20, but that's evenly divisible by 10. And I'll just keep going for a while. So 32, 62, 72. And then we'll do the same thing here. So x could be 2, but this time I'm going to add 15 because I want all these to be congruent to 2 and mod 15. So the next one would be 17. And the next number after that would have to be 32. And then add 15 again, and 47. And add 15 again, I get 62. Now what I'm looking for is the smallest common number other than 2. Now, I don't know what this one will do yet, but it turns out the answer is going to be 62. But I'll keep adding here a few more. 15 more would be 77. And 15 more, and that gets me 92. And so 92 is common, but it's bigger than 62. Add 15 more, and that gets me to 107. Okay, that's probably. Okay. Now we'll do the same thing here. All the numbers congruent to 2 in mod 20. So 2. The next one would be 22. Now it is common to these 2, but it's not because I got to have this number be common to all 3. So 42, and as soon as I hit there, stop. That's the smallest number that is common to all 3. So the least number of tickets. Now, if I kept going, I could get 82, 102. So somewhere up the line, there's going to be a another number common to all three. I'm not sure where it is. I'm not sure I can. Because I've answered the question, right? 62 tickets. Any other questions?
You don't lose points in a different way, right?
But I certainly, want to, how did it connect to what we were working on?
Yeah, I just did LCM, so I did flipper.
Found the LCM of the three. Is the LCM 62?
60, then I just had 2 on the end. I have 2 extra beyond that.
Okay.
Do you want me to, should I write that down?
That's okay. That's okay. Okay. Now, are there any others? So I asked, are there any others? There's one that I'm thinking about in particular. One of the computation problems. Did you have to divide into a negative number? Yeah.
Is the answer a negative number?
No. No. So if you divide by a number, I don't remember what the mod was in that problem. What was the modulus?
Did you send those to us?
I think I did.
Yeah.
Yeah, it should be a picture.
You sent me a picture of the last one. But I didn't get a picture of. Yeah, I did not get that. Well, I was virtual last.
But
Yeah.
but you got my email for Zoom, right?
Yeah.
Then, yeah, I'm not sure why.
I've got a list of people sent to. What's your email?
Yeah, should have been in there, because all I do is, I'm kind of still old school, I just have a Word document, and I have all your email address, and I just literally cut and paste it every time I send a Zoom invite. Yeah, sorry you didn't get that. Let me, let's check this real quick. You got the Zoom invite. No, it's not your fault. I just, I'm not sure what happened there. Just want to make sure you are.
I stayed after, and I was talking to you about the one before. Remember you sent me that picture?
Uh-huh. Yeah.
You said check your email then. I got that picture, but then I didn't get anything else from you.
Okay, I'm baffled now. All right, hold on. I want to check this.
I'm sorry.
Ah. Um. Okay, Madison, right?
No.
Oh,
Kelsey.
I'm sorry, Kelsey.
It's okay.
That was Monday, right?
Yeah.
And I sent you. Okay, I can't even find that email.
I haven't, it has a list everybody went to.
Well, I do too, but what I was looking for, you said I sent you. I can't find the email that I sent to you. Huh, okay, this is getting done.
I will make sure you get it this evening. How about that?
Okay, let me check something else here real quick. Okay. Okay, is your email have SPENCE in it?
Mhm.
Okay, you are in my email list.
Okay.
So, now did somebody send you the homework problems?
Yeah, Michaela sent it.
Okay, I have, now the next thing I want to check real quick is,
I've never had it happen before.
Well,
So
no,
funny.
it, okay, and now I'm checking the homework problems themselves, and you are in that list.
Okay,
So, I have done this before, just inadvertently deleted an email without realizing it. And so you should have a deleted file. You can check in there. And if not there, check spam file. But you are in my list. Okay, I apologize that you did not get that. Who knows? Technology. How did we ever get along without it? Okay. How old am I? When I started working here, I had a 12, when I got in my office, I had a 12-inch monochrome monitor hooked up to a back system down the hallway here. Does that make sense to you? So we're talking like, just imagine a little 12-inch screen that was green. That's it. There was no internet. So we didn't have internet. We had email. It was, which I never looked at. So, and, of course, I didn't even start using a word processor. I was still using a typewriter up through my senior year of college, literally a typewriter. And so the first time I was a senior, and I used Word Perfect. And I thought it was the second time. I couldn't, I was like, you gotta be kidding me. You have to use, correction tape and all this other stuff, so. Come a long way. All right, you guys have any questions? And the negative, that was where we were. Okay, read me the problems. It's number 9.
2 times negative 23.
2 times -1, 3, and
23.
23. Okay.
And it's mod 5.
And mod 5. The deal is if you multiply these two, you're gonna get what, -46, right?
Yeah.
And we want to divide 5 into that product. Find the remainder, and that will tell me the number between 0 and 5. Now, the number, if you got a negative answer, it may very well be congruent. The number you get congruent to negative what? 46, but we're looking for the answer that is either what, 0, 1, 2, 3, or what? 4. So how do I obtain that? What answer did you get, incidentally?
I got -1.
Negative
That's
what?
I had. 1.
Negative 1?
Yeah.
As your answer?
Yeah.
So we're looking then
Does
for,
that mean it's the opposite and 4? Is that how it works?
so if you just add 5 to that, you're gonna be set at what? 4. Okay. And that's gonna be the actual answer. So how do we get it directly? So what you did would work. Okay? You just have to add the 4 or add the 5 to get the 4. But how could I just do it directly here? So what I would do is say, how many times does 5 go into 46? It's literally on my calculator, 46 divided by 5. And you say it goes what? 9 times. That gives me what, 45, right? All right, so this is a little add. First, make the quotient negative. And since that went in there 9 times, we got 45. I'm gonna bump it up 1. Now, -10 times 5 is negative what? 50. And then when I subtract, that's double negation. So that's -46 plus 50, which is what? 4. And that's the answer I'm looking for. And again, between 0 to 4. Now, he got -1, which -1 is going to be congruent to -46 in mod what? 5. So now, so what you did was you just simply made the quotient -9. And you got negative what, 45. And so that gave you -46 plus 45, which is -1. So if you do it this way, then on the back end, add what? 5, and that would still get you. Either way is perfect. Either way will work. We good? All right, another question. You good? All right. You guys have any questions? All right, so if not, you guys email me a copy of your work. It doesn't have to be spot everything right on, but you have worked through every copy. So if you want to turn that in now, I will take it. Make sure your name's on.
I'm sorry.
No, you didn't get.
I'll make sure.
You didn't get it till 5 minutes ago.
I'll make sure it's to you this evening.
But, I would. Your picture?
Yeah.
Did you get the memo?
Yes.
Okay. All right. That's it. Did you guys figure out what day of the week you were born? You know? I have to confess, I'm pretty sure it's Wednesday. I always forget. It's either Wednesday or Thursday. I'm pretty sure it's Wednesday. And
What day of the week, what? did you say?
that you were born.
Oh,
Remember?
oh, yeah, Thursday.
You were born on Thursday?
Yeah,
Okay.
actually, if you go to your calendar on your phone, it'll go all the way.
Oh, you can.
That's
It'll go that far
hilarious.
back. I didn't- So that's an easy.
That's hilarious. I didn't know that.
I didn't know it would go that far back. I've never tried before. Like,
You have a-
before this phone could have ever existed.
And that's an
Yeah,
app,
it's an
right?
iPhone. It's way, I was born way before the iPhone. Okay.
Well, I mean, it would have to have that kind of,
The ability to track it.
yeah, and I can see how you could, you know.
I'm sure my mom would have known. but,
Oh, yeah.
just didn't just let it.
Anyhow, yeah, I didn't even know you could do that. That's fine. Then again, I'm not too far removed from a flip phone. My wife told me a few years back. She was,
I'm
yeah,
sorry.
either I upgraded or she just couldn't be seen with me anymore. So,
My father-in-law still has a flip phone and he refuses. And he's not. We've been bugging him for years, but
yeah,
it still works. He
So-
says, there's nothing wrong with it.
and I got a, I don't know, iPhone 4 and,
That's gonna
and then my
stop
wife
recording.
upgraded me the next year to a 5. And I drowned that one. And I was kind of getting into it, to pictures and, you know, videos and had a few apps. And we were kayaking out on a really hot day. Just wasn't even my head. And I come into the dock and I stuck my left leg out. And it must have dropped 8 feet. Because anyway, of course, my leg just kept going and I rolled. And it was so hot. I mean, I was dying. So the water, I'm just submerged in the water. And I could hear her yelling. So when I came up, my wife's screaming, "Your phone." Oh, yeah, so, was in a backpack, I got the backpack, it never worked again. I was able to pull all my data and all, you know, pictures of kids and grandkids and whatnot. And so
Did you put
I
it in
saved all,
rice?
yeah, got all the data off of it. but-
Not even rice.
Yeah, I tried to draw it out, but it just didn't, never function. But I was, so I got the 11 or whatever that is. And it did it, you know, just put them side by side and they linked up and birthday problem. So you're gonna want something to write on. We're gonna do a calculator. We'll do a lot of calculations. So just keep reflecting back to the autistic student that I had years ago that asked me, when were you born? I said September 15th, 1966. And he said we were born on Wednesday. I think it's Wednesday. That quick, I mean, literally instantaneously, he told me this. So before we can do this, now again, it's gonna involve using modulus. Take a guess what the mod would be.
265. 7.
That's, yeah, okay. I wasn't a bad person, but 7, there's our what, 7 days to what? All right. But now, this is kind of old school now, this notation. If you've had college algebra, you would have seen this function. And it's now represented this. That represents. Remember that from college algebra. How many people have had no clue? Either one. That's good. Okay, fair enough. So college algebra is the study of functions. And functions can model so much real world phenomena. And basically, for a function, we have some sort of relationship between a set A and a set B. It's a function if every element in the set A is corresponded to one element in set B, one and only one element. So to simplify that, just use a machine analogy. I have a machine, it's got an input. Put something in the machine. As long for that one input, there's only one output, it's a function. If you put one thing in and get more than one thing out, it is not a function. So college algebra is a study of functions. And so every time you learn a new function, you have to learn what's the rule. What's the rule to plug something in and get the output? So some real easy functions. That notation look familiar to you? F of x, function of x. Of course, we could use any letter here we want. And this actually represents the whole output person. The input's right here. So called the identity function. Put in something and the output is that what? Something we put in. Square function. Put something in and what? Square it. Put in 2, you get 4. Put in 3, you get 9. Absolute value function. Then -3, the output is what? 3. But again, in all 3 instances, 1 and only 1. Now, again, we used to use and switch to that. And why did it switch to that? The advent graphing calculator. Now, to me, it's still a mystery. This one on the graphing calculator looks like this. These are the same thing. But we still use the goalposts. That's what you find in the textbook. But this function, what we're going to call the greatest integer function, on the graphing calculator, it looks like this, int principal. And books just started using this. And so you're hard pressed to ever find this notation. But they both mean the same thing. These are both what we call greatest function. Now, what is the greatest integer function? So it's just, what's the rule? Now, every function has what's called the domain. That's that set A. The things that you are taking to what input. So the domain of the greatest integer function is any real number. You can put any real number in here. You can put in pi. You can put in the square root of 2. You can put in 1. Put in -5. Put any real number in there. The output is the greatest integer that is less than or equal to whatever you put in there. That's the rule. The greatest integer, the biggest one that is less than or equal to whatever you put in there. So how's that going to work? So if I put in, let's just do 4.5. So biggest integer that is less than or equal to 4.5 will be 3. The biggest integer that is less than, oh, my bad. Yeah, I'm sorry. It's still the biggest integer that is less than or what equal to. So less than or equal to, so if I put the output is still what? 4, less than or what equal to. Now, always be a little careful with negative ones. Now, what is the biggest integer that is less than or equal to -3.5?
-4.
-4. Is that right? Because here's negative what? Yeah, 3.5. So here would be what? -4. Less than or what? Equal to. So it's actually a fairly simple rule. It's got kind of a crazy graph. We call it kind of a step function. Because you put in 0, the output 0, move over to 1, and then at 1, it goes to what? 1. And you show an open hole in the graph. And then between 1 and 2, you get all the same output. And so what you end up forming is this kind of set of what? Steps. It's called a step function. Good. Though you would not consider this function to be increasing or decreasing. It looks like it's moving up, but actually it's just a series of what these little horizontal segments. Okay. So what we're going to do is going to involve this greatest integer function. That's why I wanted to go with it first. So we good with that? Okay. You guys all good with that? All right, so what I'm going to do now, I want more space here, so I want to erase this. So we good? Let's go figure out what day of the week you're born on without using your phone. All right, I got 3 inputs. Day, month, year. All right, so as I work this, I'm going to work along. You're going to have your own notes. I'm going to use my birthday. Totally give away how old I am.
4-digit for you?
Yes, 4 digits for the year. So on the day, that's easy enough. Day for me on the 15th. Now on the month, March is 3, single digit, not 0, 3, just 3. April's 4, May's 5, up through December would be what, 12. But if you were born in January or February, for January, use 13. And for February, use 14. Okay. So for me, I'm born in September. So write down whatever your number would be. All right. Now, the year. Use your year unless you were born in January or February. So picking on all you January Capricorns and what else is? What else? Where's the other astrological sign? I don't know either. I don't know into it. My wife is. I don't know. I know Capricorn just because she's a Capricorn. But if you're born in January or February, use the previous year. So if you were born in 1990 of January, use 1989, right? If you are born September, so I'm good, I was born 1966. Good? Why would I be making these adjustments, do you think, for January? February? It's not really January's fault. It's February's fault.
Short of that, short of growth.
Okay, it is the shortest month. I will agree with that. Some leap year, good old leap
Sometimes
year.
it knows.
Every what, 4 years, we only have what, 28 days, right? We lose that what? So if you were born on February 29th,
No, we only get 29 days.
that's it. That's,
Yeah.
I've got it backwards.
It's
Yeah, yeah,
always
yeah.
28.
It's
always
Sometimes
28,
it's 29.
But so if, yeah. But if you were born on a leap year on the 29th,
Yeah.
you only get to have your birthday every
4 years.
4 years. That's just how it goes. Okay, and that, it has to do with, because we're on what, solar count. And it has to do with making a little bit of time. It's not perfectly modeled to rotation around the sun. Okay, so we have all these. So we are going to put together a big old equation. We're going to find the number W. Eventually. It's going to be equal to E plus 2 times M plus greatest integer of 3 times M plus 1 divided by 5 plus E plus greatest integer of year divided by 4 minus greatest integer of year divided by 100 plus greatest integer of year divided by 400. Just remember, it did this fast. Okay. So now it's a matter of going and doing the calculation.
So you'll get an answer of 1 through 7?
Not yet. You're gonna get a big number here.
Oh, okay.
So I'm gonna put in my numbers. Put in your numbers. All right. 3 times 10 is 5 is 6. 6 is 6. So then when I do this one, I will just divide the year by 4.
FNIT.
No, so if you want to find the greatest integer function and actually use it, go to math. And then move over to 1 over to NUN. And then you can see the item how it did. Okay. Oh, I'm doing old school here. 1966 divided by 4. 491.5. So 491. Minus, now that divided by 100 would be 19.66. So greatest integer less than or equal to 19.66 is 19. That would be 1 point. Wait a second, that was 400. That was, yeah. 1966 divided by 400. Greatest integer less than or equal to 4.195 is 4. So, all right. Here. 15 plus That's 4. Okay, got my number. Got your number?
I think so.
Okay.
Well, it's kind of close.
Just remember.
Should it be like within?
Yeah, I mean, you're,
A little different.
it's gonna be different. You know, I'm estimating you were born in the 90s.
Yeah, late 90s.
So, yeah. And, so that's gonna make it a little bit different right there.
Yeah. Oh, it's different. It's not the same.
But you're looking for something in thousands. Got a number? Everybody's got their number. What you have. Good, good. All right, we all have a number then? Yeah.
Yes.
Okay. All right, so how do we get something between 0 and 6, right? Because we are dealing, we're gonna do this mod 7. So we're gonna take this and we're gonna set it, the equation, this is the modular part that kicks in. I'm gonna call this R. I want W congruent to R mod 7. Now W we know. 2, 4, 8, 1. R. 7. So it's just divide your number by what? 7. And find that remainder, 0 through 6. 4, 8, 1. In that case. Divided by 7. And it's 354 times 7. 2, 4, 7, 8. So for me, R is 3. My remainder is 3. Now, I was born on Thursday. Again, I can never remember. So,
We're doing the Monday start, because some people do.
no, so it will be 0 will be
Sunday?
Sunday.
Okay. I think
Um,
mine's on.
no, my bad. My bad. 0 is Monday.
Oh.
1
Yeah.
is Tuesday.
Okay.
2 is Wednesday. 3 is Thursday. So 4 will be Friday. Saturday. 6 will be. Yes, sir. That's exactly right. So if you, then you were born on Monday. Okay, so I'm gonna do one more thing I've never done, because I didn't know you could even do it until today. Take my iPhone here, and you may have to walk me through this.
You go to the calendar app.
Okay, so I'm in this calendar.
Yeah, and then like just scroll up, so it goes to the years before and then just go. Like, like, yeah,
Like this.
and just till you get to your.
Oh.
Yeah.
Whatever you. Okay, like, so I'm gonna have to.
Takes a little while.
Oh, no, heck, I'm in 1951.
Yeah, it goes bad. It goes.
I'm not
I
that
don't know
old.
how far it goes.
That's crazy.
I watched a video of it online and it goes back all the way to Lincoln.
Oh, really?
Mine's
Yeah,
like
like the-
1817,
Wow.
16.
1966.
We're back to 1501 already.
September, yep, I was born on Thursday. Early died on Saturday. That's cool.
Weird.
So I thought there was some sort of No, it's just literally,
And
they've
it
got
goes the
every
other way
year,
too.
and it'll go, if you want to keep going, it'll go to
I was
one.
gonna say, it goes the other way too. Like,
So you're doing to the future.
you can go into the future.
I think you could accompany it, but I never really
Yeah.
tried.
Wow, that's,
Mine's all the way up,
That's great.
like, I went all the way up to like, it's already up to 2108.
Well, yeah.
Yes, we will not. be over.
okay. So, guys, I'm gonna step the other computer here, I'm gonna fire it up real quick. Get my math lab called up. So anyway, cool little,
I bet there's an online calculator for that too, like, in it, kind of, we can just put it in.
oh, yeah. I mean, this would, to me, you know, if you're into coding. you could
Not
have
that
that. And so that you literally just input those three things and it would crank it out. But to me, it's just, again, the power, that the ability to process it instantaneously. Now, he could not explain how he did it. You know, nor do I have it, because I'm very sure it's not this way. I mean, it's, you know, literally, is he just running back through the calendars in his head? I don't know.
Like, you just memorize it.
Yeah, I mean, just, that, you know, that's exceptional. That is. So still this day, it, now he had,
Maybe memorize the patterns, like how many days off each year is for the week, and you just kind of.
yeah. Definitely had other social issues for sure, but, that's. All right. Yeah, it's good. Yeah, enjoy the nice weather. I think after today, it's gonna, well, depending on what your perspective is. I want it to get cold, so, sorry.
It's gonna rain tomorrow though, so that goes.
Yeah, but if it's raining here, it's snowing in the mountains.
It was
So it's just-
snowing a little bit a couple of days ago.
Be some slushy, gross stuff.
Yeah, well, I saw, we have a few birds here, but they have been for a few weeks now, making snowshoes. They will be, their planned date is the 23rd, which is actually not for general public, but for season pass holders and employees. Then third, and then Wednesday, I think that's a Wednesday, 23rd, Tuesday. Wednesday, they'll open, now they'll have like 11 trails, so. But, you know, we lived out west, we've been skiing for a month. We'll get the deal out there.
Been skiing and deer hunting and living around and stuff.
Me?
Yes.
Yeah, I don't, I'll be honest, I'm lazy now, and my passion's skiing,
Yeah.
and my daughter and son-in-law, you know, they give me enough venison to get through the year. So I'm old school that way.
My brother always goes, end up dragging it off and go with it anywhere, so. That's not too bad.
But that, you know, that explains, but that is exactly why it is what it is. I mean, should our week break occur at the end of the semester? Heck no, it should be halfway through the semester. It is in March, you know, we have it, what, March? It's literally just at the halfway point. So, you know, it is every fall. It's the same deal. It's been this way here since, and if you go out of this area, they don't have a fall break like this at the end of the semester. So what ends up happening, everyone's burned out. And this semester even more so. I'm turning you guys so you can see the screen. And and you go home and go hunt, go ski. eat a lot of turkey, mashed potatoes and gravy and stuffing and pumpkin pie and sit around and watch football all day and sleep. Comes around next Monday, that last week of classes, who's into it? You're done. You what wrapped up during what, your fall break, because you're done, and it's very normal. And so we always have to acknowledge that we still have a couple of weeks left. It's tough. But the reason we do it, if in this area, that opening day of gun season is always that Monday of that week. And if we tried to have school there, you'd have half the faculty, half the staff, half the students, at least not here. It's just always been that way. Okay, so we are looking at test. So just to kind of recap where we have been. This is chapters 4 and 5. And so as far as what we have covered on my math lab, it was what, 4-3, 4-4, 5-1, 5-3, and what, 5-4. So I'm just going back. Looking real quick. So 4-3 was just the what, lattice method, Egyptian algorithm, and Russian peasant method. What whole lot there. 4-4, there was a whole bunch. Now this was where we looked at working our numeration system in other bases. So just total understanding of what that means. And the ability to be able to take a number in another base, convert to base 10, write it out in what expanded form out of products, and also we learned the calculator shortcut, and take a number in base 10 and write it using a division and finding remainders to convert to any base that we want. And direct conversions between base 2 and base 16, base 2 and base 8, back and forth. And also ASCII application. Chapter 5. 5.1. Visibility. And then what, prime numbers. Prime, what, listing out factors of a number, listing out prime factors of a number, using prime factors to find LCM and GCD. Rules of divisibility. I think there's anything else here. The visibility test for 11.7 that I'm not going to put that on. That's finding total number of divisors using a prime factorization. Okay. 5.3 should be your LCM. Well, abundant, efficient, perfect. And 5.4. There's your GCD and LCM. Now, I'm not assigning this today yet. I need to go in
do some editing. See where it says what, final exam, so I will remove that, it's not your final exam. Oh, didn't want to do that. Wrong. That. Okay, so right now it says 15. And there's 4-1, 4-3, 4-4. See quite a few from 4-4, but that's what different number bases. 5-1, 5-3, and what? 5-4. So it's 15 problems. It's not anything what earth shattering or difficult. Find what products using what Gibson algorithm, lattice method, what Russian peasant method. Counting numbers and other bases, that's where you go 0, 1, 2, 3, 4, 5, say your base 6, get to 5, then go 1, 0, 1, 1, 1, 2. It says convert between decimal form and bases other than what? Base 10. So these are all just conversions. Again, either from base 10 back to some other base, or excuse me, yeah, to some other base or from some other base to base 10. Convert between decimal, binary, octal, and hexadecimal forms into context. So there we're looking at direct conversions. The visibility tests, listing out the factors of the number, prime factorization of the number, identifying the deficient, find the greatest common factor, find the least common multiple. So this work that you'll either be turning into me or via email, thank you. Or you've already turned it into me today. What I'll look to do with it, because obviously I can't without testing, I don't have the problems in my math to do that. But I don't want you just to, you turned it in, so I want you to get some credit for it. So what I'll look to do is add it, just like I would a paper, as an offline item, but within your, basically as a homework group. As long as you attempted every problem, turned in good work, you'll get credit. Okay, so if you didn't turn it in, then just like any other homework assignment you didn't do, it's going to zero. So, any questions? All right, so when you guys get out of here, I'm going to go ahead and I'm going to hit pause.